Hi everyone, Tara here, and this is going to be on my rock and mineral collection. This one won the poll, which surprised me a little bit, and I hope you enjoy it. When I was 4 years old, I went to the Smithsonian Museum of Natural History, which is this building here. And ever since then, I've been really interested in the natural sciences, and particularly rocks. I would sit in my driveway, which was gravel, for like hours and pick out all the ones that I thought were pretty and keep them in a plastic flower pot in my room. Most of those turned out to be granite. And what I wanted was to someday have the equivalent of the Smithsonian's collection of rocks and minerals and gemstones. When you're 4, you don't really understand that that's not possible to have the National Museum stuff, but that's what I wanted. So I just collect a little bit of everything. Most of my specimens are small, with the exception of a large one or two. And I want to say I am not an expert. This is just a hobby. And if I say anything that is incorrect, I do apologize. This is the first actual mineral that was ever added to my collection. My dad got this for me from our local nature center gift shop when I was 5. It's just a clear quartz point. And quartz is one of our most abundant minerals on the earth. It can be used, the really clear stuff, for high quality watch faces, or the clear bezel that goes over your watch. It's used a lot in electronics due to its piezoelectric capabilities, which means if you were to compress a piece of quartz between two pieces of metal, while the quartz itself is not really conductive of electricity, it will actually generate a small amount of electricity. This is bloodstone jasper. It's a quartz-based mineral. Usually has a lot of really dark green and red in it like that. This is a sphere of honey calcite. It was not labeled. I got it when I was about 14. Here we have black tourmaline. And then on the other side is what's called Hyalite opal. All these little globby clear bits are the Hyalite opal. So here is the cabinet with the light on in it, as you can see. And I'm going to shine a 365 nanometer black light at it. And you can see how brightly that glows green. And if you've ever been to an antique store and you've seen dishes where they have them set up with a black light over them, those are called uranium glass. So you may recognize this particular hue from that, and that is the impurity in this Hyalite opal that is causing it to glow this green. I'm not exactly sure how hot it is in terms of radioactivity. I don't have a Geiger meter. I just, treat it with respect, wash my hands after touching it, and don't sleep with it under my pillow or anything like that. And if you give me just a second, I'm going to turn off some other lights. So I have some photos and papers on the desk, but I am all the way across the room, and you can see how bright that thing is. And the same thing goes over here for this piece of Adamite. Same green color, same uranium impurity. This is the Adamite under a regular LED light. It is on limonite. I bought this piece when I was 15 and had no idea about the uranium impurities or possible radioactivity of this rock. On the back, you can see it also looks like there are some botryoidal hematite little pieces there, and some more of the crystal structure. When I got this, they offered to wrap it for me at the store, and this particular store is kind of rough with things, and I knew how brittle it was. You can see there's like some little needle fragments from it on the glass shelf with it, and I was like, no, please don't wrap it, I'll just take it. So I held it in my hands on the way home and got 2 needles from it stuck in my finger for like 2 days. So I don't like to handle this one. The golden fibrous looking needles are rutile, which is a titanium. And then the silver metallic parts are called sphalerite. And if that'll focus on it there, you can kind of see the crystal structure in that larger piece toward the bottom of the screen. And that is a zinc ore. I also have this polished piece of it, and that is possible because it is in quartz. The name for this is rutilated quartz, but it also does have some sphalerite that I think you can see a little bit better from the back. Similar to the rutilated quartz, this is a little carved and polished pyramid of tourmalinated quartz. So rather than rutile running through the quartz, it has these tiny little needles of greenish to black tourmaline. This is a mineral called crocowite. This is a lead and chromium mineral, and then it is on limonite. That's the host rock. It's all these super, super fine little needles in it. If you have any chrome on anything in your house or on your car, this is what it can look like when it comes out of the earth. It is a lesser ore of chrome. This is a polished example of prehnite with a cavity that's open there with some rough mineral in there. And then all the little dark streaks that you see are the mineral epidote. And this is a silicate. This is a totally rough form of prehnite, and you can see all these little tiny glittery crystals that make up these rounded globular masses. I guess that would be called botryoidal, which is just a fancy mineral word for rounded globular masses. The sort of light yellow crystals here are barite, and this is our major ore of barium. So the industrial application list for this is super, super long, includes but not limited to filler in paint and plastics and radioactively protective cement, whatever that is. And if you've ever had to drink barium for a CT or an X-ray, this is where it comes from. It is on chalcopyrite with some calcite on it. This is an ammonite fossil, and if you can see, there's a little bit of a gold sheen to it. That is because there is pyrite as a coating over the top of this that just occurred naturally. This one is dioptase. It is a hydrous silicate of copper. This is one of my very favorites because of the color. Teal is my favorite color, and I just think this piece is beautiful. This is a piece of rough chrysocolla, another copper-based mineral. And here it is in polished form. Just a tiny little red jasper sphere here. So this is another quartz. This is a pink amethyst. And I just really liked this piece for this white crystal that it's got, that looks like it's just sort of carefully balanced on here. This is the yellow form of mica. It does come in a few other colors. It has some nice triangular shaped blades. And now we have a purple lavender form of mica. The name for this is either lepidolite or lepidolite. I'm not exactly sure how to say that. You can see that same sort of sheen on the like thin sheets. The stone here is a combination of epidote. All of the green is the epidote crystals. The triangular tabs of sort of a mauve color is more lepidolite. And then there are some clear quartz crystals on this piece as well. This is chevron amethyst, which just signifies the sort of chevron shapes that it gets with this white banding that goes through it. And I just liked it because I had not seen chevron amethyst in sphere form before. Here we have an amethyst and calcite geode. This is hemimorphite. It is a hydrous zinc silicate. It comes in other colors. The blue is not really showing up on camera, The blue color is likely caused by some copper impurities, and this one can be confused with smithsonite and can occur with smithsonite. This is a thumbnail specimen of aquamarine. You can see there is a larger, very clear crystal on the top and a smaller little crystal on the bottom here. This is on calcite. And aquamarine is blue beryl. So beryl is where we get beryllium from. And the blue form is called aquamarine. The green form is called emerald. There is a pink form called morganite, which I can actually show you. This is a super tiny, like 5 millimeter faceted piece of morganite in trillion cut. It's very, very light pink. And then there is a yellow form called heliodor. Those are all sort of gemological trade names for the different colors, but it's all just beryl. For green beryl, I have a few examples. This one, I believe, is from the United States, and there's some quartz with it. You can kind of see the crystal structure it takes on there, similar to the aquamarine. This one is also, I believe, from the US. And then this one is from South America. It's a little bit gemmier, a little bit more intense color. The crystals on my specimen of it are very, very small. This is the 3 emeralds up here under the UV light, and the South American one glows red. And I have some polished pieces here. This is another type of jasper. I am not sure what the trade name for this type would be. A little bit of red, a little bit of green. I just liked it. It's pretty. This is another clearish quartz crystal piece that has been polished. My camera does not seem to like the color green today. This is slightly olive green. It was more olive green when I bought it, and it was just sold to me as green quartz. I did not know that this was likely an irradiated piece of quartz to make it that color. I've had it for about 20 years, and over the course of time, it has sort of softened into more of like a smoky quartz look. There on that little facet on the left bottom, you can see a little bit more of the green color. Kind of depends on the way you turn it. So I'm kind of interested to see if like over the next several years, this is going to change even more. But there are so many types of treatments for quartz to affect the color, the irradiation, like I mentioned. There's also heat treating and vapor coating with metals, and there's probably more. This one is Wavelite, which looks kind of similar to the rough prehnite that I showed. Some Wavelite is UV reactive. Mine, unfortunately, is not. So this is another one of my older pieces. I think I got this one also when I was like 15. This is apophyllite on stilbite, a little tiny bit of calcite on the top there. The clear crystals are the apophyllite, and the peachy pink tabular ones are the stilbite. This is a fossilized clam, a small one, and it's been polished. This is another larger fossilized clam. This is a piece of fossilized coral that I found near some train tracks. And I think if I can get this to focus, there are some nice little druzy bits in there. Super tiny, fine quartz crystals. And I don't know the exact type of coral. But coral fossils are super, super common in Michigan also. And our state stone is actually the Petoskey stone, which is just another type of coral fossil. This is called azurite, and this is another copper-based mineral. It has monoclinic crystal habit, which I felt like this piece really kind of showed that off nicely. This piece is from a mine in Morocco. People used to make this into a pigment for paints and cosmetics. This is a polished example of azurite in slab form. This is not the best example of tourmaline. That is actually one of the things I would like to acquire soon. On the back here, there are some really dark green to black crystals. And then the reason I like this piece is because there is such a thing called watermelon tourmaline, which, like a watermelon, is green on the outside, but pink on the inside. And this crystal displays the reverse of that in this spot here and over here. This is peridot. It's a type of olivine. The rough form, the lime green crystals, are the peridot, and then the darker green is epidote. And then on the bottom is just a small faceted version of it. This is another fairly common quartz-based mineral. This is called tiger's eye. Quartz is what gives it its glassy appearance. The color comes from iron oxide, and what gives it its chatoyant appearance is fibers of asbestos. This is not the best example of a fire opal, but you can see a little bit of play of color through it. This one is wolfenite on limonite. The yellow crystals are the wolfenite. And this is a lead molybdate. So it is comprised of lead and molybdenum. This one, I believe, is calcite or calcite with a little bit of quartz. I'm not 100% sure. It was not labeled when I purchased it. You can kind of see the crystal structure on it. And it does glow blue, focus please, under ultraviolet light, which I can show you. This one I am not 100% sure, but I think it is galena or lead ore. I got it for 50 cents unlabeled at a flea market. This is a nice little thumbnail specimen of naturally colored topaz here. I'm not sure where in the world this piece is from, but topaz comes in a ton of colors and it's used a lot in jewelry. When it's used in jewelry, it does tend to be heated to enhance the colors. Here we have a couple of examples of kyanite, which is an aluminum silicate. It is used in porcelains and fire brick and sometimes spark plugs. This is celestite. It is a strontium sulfate, and it comes in white, colorless. It can be brown, but the blue versions like this, the blue is caused by a teeny little trace amount of gold. And this is another example of it with very, very small crystals. But this one, I'm not sure. This is a piece of glass. This was included with some seashells that my great-grandmother actually sent me when she went to Florida and was combing the beach for seashells. And I believe this is what is known as a fulgurite. And that is when lightning hits sand. So it has a little bit of an atypical shape for a fulgurite. Usually they look like all really zigzaggy. And this one has a little, obviously more streaky shape to it. There is a name for this shape that I am just blanking on. And if we look really close, you can see some little bits of grains of sand still stuck in the crevices of this. It's interesting. This is a little sphere of sodalite, a sodium aluminum silicate with some chlorine in it. And this is sometimes dyed to enhance the richness of the blue and fake lapis lazuli, but you won't find pyrite in sodalite. This can also fluoresce orange under long-wave UV light. Mine is very, very slight, so I didn't think it would show up on camera. This is actual lapis lazuli, another sodium aluminum silicate, and you can see the little bits of gold colored pyrite in it. This one, like azurite, has been used since antiquity to be ground into a powder and used as a pigment in cosmetics and paints. And when that is done, the pigment is called ultramarine. I have a vintage tube of it here. They don't usually use this in oil paints anymore. It's usually synthesized because it's very expensive to make this. But I do have a few retro tubes of this. I actually used it a lot in this painting I did of my first betta. I feel like you can see it the best like here and up and through here. I have some examples of fluorite here. This is where we get fluoride, although most of the fluoride that is used in toothpaste and municipal water treatments is chemically synthesized. The gaseous form is toxic, also breathing in the dust from this. Fluorine, which is the gaseous form, was used in World War II. This stuff comes from all over the world. A lot of it comes from China, but it can also be found in the US and Mexico. And this is a little drawing I made of the octahedral crystal form. This can have it in nature, as I don't have an actual example, not this one. That one didn't turn out very good. This piece shows fluorite in its cube form, which is formed under lower temperatures than the octahedral form. And this is from Ohio. All of the Ohio material seems to have this sort of root beer colored crystals on it. This particular piece has some clear quartz down here. And unique to the Ohio material, this will fluoresce yellow under long wave UV. So the two examples on the left are glowing a bright bluish purple. It's actually a little bit more purple in real life than it's showing on camera. And here you can see the yellow fluorescence of the Ohio one. And if you're still with me at this point in the video, leave a little rock emoji in with your comment because you rock. This was a long one. And I think I'm going to wrap it up here for part 1 of this. Next time, it's going to be a lot of metals, more fossils, minerals, and gemstones, and some of my very favorite showpieces. So thank you very much, everybody, for watching. I really appreciate it. And I hope you're having a great day. Bye.